In this video, we're going to be learning about the type of formula that characterizes an arithmetic sequence. Now, I'm going to go right ahead and give you the formula. Any arithmetic sequence will be described by a formula looking like this. Un is equal to d times n plus c. And I'll go right ahead and box that in red here. Now, what this is telling us is that the nth term will always equal to d, which is the common difference, times n plus c. So the nth term could be the 30th term, for example, in which case u30 would equal to the common difference times 30 plus some constant, some number c, which we'll learn how to work out later on. But now I'll just write this below. D is the common difference. It's quite an important thing to remember there. Now let's go ahead and start. Let's say we were given the following sequence: 3, 7, 11, 15, 19, 23, and so on and so forth. Well, what I'm going to do now is give you this sequence's formula. This sequence's formula is un is equal to 4n minus 1. Now what this formula will allow us to do is to calculate any term in the sequence. So say for instance we wanted to calculate the third term, and imagine that we didn't see the terms with that we had above there. Well, the third term, to calculate it, all we would have to do is replace n inside the formula, and when I say inside the formula, I'm referring to this n and this n. All we have to do is replace n by 3 to calculate the third term. That would lead us to this: u3, which simply means third term, equals to 4 times 3 minus 1, leading us to 12 minus 1, which is equal to 11. And now, looking at our sequence here, we can definitely see that the third term is indeed 11, which is what the formula just gave us. Or let's say we could calculate the fifth term, in which case we would have replaced n by 5, leading us to u5 equals to 4 times 5 minus 1, which is 20 minus 1, which is equal to 19. And indeed, we can see, looking at this formula, that the fifth term is definitely 19. So this formula is working. But what's powerful with this type of formula is that we can calculate any term inside the sequence. Now what we see at the top of this page here is that we're given the first 6 terms of this arithmetic sequence. But what if we were asked to calculate the 20th, the 30th, or the 100th term of the sequence? Well, sure, we could carry on with the sequence and just keep on adding 4, going 27, 31, 35, and so on, all the way until we reach the term that we wanted. But let's be honest, that definitely wouldn't be a practical way of doing things. This formula here, un equals to 4n minus 1, on the other hand, gives us a method to calculate any term directly. So let's see. Let's say we wanted to calculate the 100th term. All we would have to do is replace n by 100 and calculate. So we would write u100 is equal to 4 times 100 minus 1, which equals to 400 minus 1, which is equal to 399. Now let's look at another example. Let's say we were given the sequence of numbers 22, 19, 16, 13, 10, and so on. Well, again, I'm just going to give you the sequences formula. Its formula is un is equal to negative 3n plus 25. Now let's just check that this formula works. Let's say we wanted to calculate the fourth term. Well, to calculate the fourth term, all we would have to do is, once more, we would replace n by 4. So to do that, we write u4 is equal to negative 3 times 4 plus 25. That leads us to negative 12 plus 25, which is equal to 13. And just as it did before, we can see that the fourth term in the sequence is the same as what we calculated with the formula. And once more, we could calculate much bigger terms. Let's say we were asked to find the 1000th term of the sequence. Well, we would just replace n by 1000. That would be u1000 is equal to negative 3 times 1,000 plus 25. That leads us to negative 3,000 plus 25, which leads us to the result, negative 2,975. And there we go. That's how we use the formula of an arithmetic sequence. I will finish this just pointing out one thing, which I mentioned before. Look at both of these formula and both of these sequences. In the first sequence, we can see that the common difference of this sequence is 4. We're always adding 4 to get from one term to the next. And that 4, remember, is what we see here, multiplying the n, which I'm just boxing in there. Similarly, in the second sequence, the common difference is negative 3. And that negative 3 is what's multiplying the n in the formula. Now, we're going to be learning how to find this formula very shortly. But for now, though, make sure that you can calculate any term in a sequence when you're given its formula.